Last week ones, please. I went in all my books, all my libraries, I might use. That's the thing. Oh, it's a picture. Okay, so these look like yesterday's. And you're like, this isn't new. This looks the same. It's different. Okay. Yesterday and the day before we were doing angles. So angles was like big arc minus small arc divided by 2 makes the angle. If it crisscrossed in the center, we added the arc. We divided by 2 and got the angle. These are not angles. These are lengths. Okay. So the length ones are nice and beautiful. Okay. They're very cute. See, very beautiful. Okay. So if it crisscrosses on the inside to find the length of one of these segments, what we're going to do is we're going to pick something. If I pick A, what's on the same line as A? B. So A and B are going to be, there's something under my paper. Oh, that's sticky now. Okay. A is going to be multiplied with B to equal the other line multiplied together. So what 2 letters are on the other line? C and D. So if it crisscrosses, all you're doing is taking the numbers that are actually on those lines. The lines multiply together and they equal to each other. That's nice. That's it. Okay. If it's got a nose, both of these have noses. Okay. So this one is 2 secant lines. Secant lines go through the circle. These are technically chords. Chords are just like stop at the end. Secants go through the circle. This one is a secant line. And then a tangent line. Tangent just touches on one point. So you have 2 secants. What you're going to do is you're going to take the outside. So if I use A, and then I'm going to multiply by the entire length of that line. So to represent the entire length of that line, I have to combine A and B. So I'm going to add A and B together. And then it's going to be equal to the same thing on the other side. What's on the outside of the line? C, and then I'm multiplying by what? C plus D. So it's outside multiplied by the line added together equals the outside multiplied by the line added together. The last one is type 3. It's literally the same as this. It just looks a little different because it's tangent. So if I pick something on the outside like A is being multiplied by the entire length of that line. Is there anything to add to it? No. So it's just A times A. And then what's on the outside? B. And then how would I write adding this together? B plus C. And that's it. So these 2 are the same thing. It's only a little different just because A has nothing to add to. So it's just A times A. So you'll really like today's. Today's is nice. It's beautiful. It's cute. It's nice. It's not crazy. The past 2 days have been crazy. So starting with 1, we're going to pick anything inside the circle. It does not matter. So I'm going to pick something. X. So X is on the same line as what? 10. So we're doing X times 10 equals, bless you. The other line has 14 and 15. So we're going to do 14 times 15. X times 10 is 10x. 14 times 15 is 210. And then if I divide by 10, X is 21. And that's it. Okay, let's go to number 2. Number 2, same thing. So we're going to pick anything. It does not matter. So what do you want to pick? 6. So 6 is on the same line as what? 6. It just so happens they're the same number. Equals. What's on the other line? 5x minus 1 and 4. I'm going to put the 4 in the front. And then 5x minus 1, because it's a binomial, which is like 2 terms, I'm going to put it in parentheses because you will have to distribute that. So 6 times 6 is 36. 4 times 5 is 20. 4 times 1 is 4. And now we solve like normal. Easy peasy, lemon squeezy. So what's x? 2. So this one doesn't want just x. This one wants you to plug it back in. I need to find BD. So BD is this whole line right here. So I have 5x minus 1. X is 2. So 5 times 2 minus 1 is how much? 9. So BD is 9 plus what? 4. Because if this piece is 9, this piece is 4, I'm adding them to make the length of the line. So BD is actually how much? 13. Okay, try number 3. Same exact thing. Something is going to multiply with the same line. The other thing is multiplying with the same line. They just have to be on the same line. What do we get? 11. And that one we don't have to plug it back in because it's just a solve for x. How do we feel? Not too bad? Way better than like yesterday, I mean. Yeah. Okay. Let's go to number 5. So number 5 is different. So the first 3 they crisscrossed on the inside. Okay. Number 5, we have a nose. So we're gonna take something on the outside and we're multiplying by the entire length of the line. So nope, but that's what everybody's gonna do. Everybody's gonna be like 8 times 19. Yes. 8 is on the outside and you're multiplying by the whole line added together. So 8 plus 19. Because it's on the same line. So what else is on the outside? 9. And then what's gonna be in my parentheses? 9 plus x. So double so for this one, you could do one of two things. You could distribute 8 to 8 to make 64 and 8 times 19 and get a number and then add them together. Or you could just add, because they're both numbers, and times by 8. You're going to get the same answer either way. So I'm just going to add them now. But you could distribute and then distribute. Or like you could distribute, then combine. I'm going to combine, then distribute. So what do we get? 15. Okay, so think about the next one. Doing outside, you're multiplying by the whole line. So you have to add the whole line together. So what's something on the outside for 6? 10. And then what two things am I adding together? 10 and 42. And I show every step. You don't have to. If you want to just, you're going to add them together, just add them together right there. That's fine. So what should be on my other side? 13. And then what's in parentheses? 13 plus x. And when you divide, what do you get? 27. And then this one you have to plug back in. No. So you need to find NL. So this part's literally just x. So that part's 27. If I'm not multiplying 27 and 13, I'm adding them. So NL is just 27 plus 13. So how much is NL? 40. Okay, so look at number 7. This is the last type of this one we're going to do. We're basically going to do like 3 of each. So we're going to skip the butt front. Oh my goodness. Like crunch time for the EOC. It's like we're just running to the end of the year. Don't fall off the bandwagon. Don't fall off. And then give up. And I'm like, I only have an F. My feet don't come to school. Okay, so what's something on the outside? 8 and 7. So let's choose 8 just to start. What am I multiplying by? Yes. 8 plus 3x plus 4. So because you're doing outside times the whole length of the line, you still need to add them together. We'll combine like terms in the next step, but for now, let's just leave it like that. Okay, on the other side, what's on the outside? Yes. So 7 times 7 plus 5x plus 2. So you're combining like terms. So you could distribute right now into everything and then solve it. I'm just gonna find like terms to start because it'll make my life easier in the long run. So 8 and 4 are both numbers, so they can come together. 7 and 2 are both numbers, they can come together, and then it'll turn into like a normal problem. So 8, and then I have 3x plus 12, and then 5x plus 9. And it could be 12 plus 3x. This could be 9 plus 5x. You're going to get the same thing anyways. It doesn't matter if it's like flip-flopped. So take a second, double distribute property. Not working. Yeah, yeah. No? Am I doing something wrong? People are giving me crazy look. No, no. That's not right. You know. Yes, we are skipping a lot. We haven't skipped a lot yet. Did we get 3? Yeah. Yeah. Okay, we're skipping 8. We're skipping where my other paper is. No, there's like certain ones I need to do. We can skip. We can skip 10. Where's my paper for last class? Just want to make sure I skip them. I don't like the same ones. Like, I think it's 10. Let's skip 10. And then we're skipping 13, 14, 15, 16. So we're basically only doing these last 3. Okay. The last 3 that we're doing on the front are these ones. And then I'll tell you which ones we're skipping on the back. But we're crossing out 13, 14, 15, 16. Because I know it is a lot. Okay. The last 3 that we're doing on the front are the last type. We're not doing all of them. Take chill, go, relax, breathe, musa, musa. It's fine. Okay. Okay. So 9. This one's the last type. Okay. But it's the same thing. So what's something on the outside? 18. And then what am I multiplying by? 18 plus x equals what's on the outside? 24 times what? 24. So the thing is, you're always doing the outside multiplied by the entire length of the line. 24 just has nothing to add to it. So it's just 24 times 24. Just like we did 18 times 18 plus x. So in this case, when you have just a tangent line, so a tangent just touches in one spot, there's no continuation of it. We're just doing that times itself. So 3, oh. I feel like we just got like ding dong ditched. I feel like they ran off. Oh, hello. Yeah. What do you think I do? Just sit here? Sometimes. But sometimes I teach, you know. Yeah.
You have to turn this in.
What is it?
It's 1:15.
No. Why?
I'll show it to you later.
Why is it like a 0?
Yes.
In the 2015 Ash. Oh yeah, I didn't mark you off. Okay, bye. My bad. Okay. So 252 equals 18x. Wait, no. Yeah, right? I just wrote it backwards because I got thrown off, but it's okay. What do I get for x? Okay, so let's move on. The last ones are a little weird, but it's the same thing. It's just got little spikes. Okay, so same thing if I take something on the outside with something on the outside. 27, and then what am I adding together? 27 plus 21. Now on the other side, I have x, and I'm multiplying by x, which is not 2x, x squared. So from algebra 1 and even like pre-algebra, you should have learned that x plus x makes 2x, x times x is x squared. So let's add this and multiply. So take a second. What's 27 plus 21 multiplied by 27? 1,296 equals x squared. How do we get rid of the squared? U square root is. A little razzle dazzle. It is 36. Okay, last one we're doing is the same thing. Yes. So if I pick something on the outside, let's use 9. In parentheses, what am I adding together? 9 plus 16 equals, now this is a little weird, but it's okay. We're doing 3x times 3x. So it's not just x squared. It's gonna be 9x squared. So how do I get rid of the 9? Nope. Divide by 9. And then I can square root it because x is technically like by itself now. So x is what? 5. Okay, so we're skipping the rest on the front. You don't have to do anything we didn't do on the front. There's 3 examples of each type of problem. Realistically, 2 are identical. Okay, on the back, we're gonna cross out quite enough. So let's look to the back real quick. So on the back, you can cross out. You can cross out 14 and 15, 3 and 4, and 7 and 8. So I kind of crossed off like the longer equation ones. If you look, like these are like double distributive property ones. This is a double distributive property one. I kept like the nicer, easier, like smaller numbered ones for you guys. When you're done with this, because most people will finish this before you go, it kind of looks like, oh, it's not. You're turning it into the bin. If you need to take it over the weekend, you can turn it in on Tuesday, but if you finish, which most of you will, just turn it into the bin, and then you can work on the EOC review, which is due Tuesday. Okay?
I need to put something on, you know.
Yeah, well, not today. Like, if you finish, you will finish. Most of you, you'll turn it into the bin.